Consider the following implicitly defined equation written way over here. What is the instantaneous rate of change of y at negative 1, 1? Well, if I'm going to do an implicit differentiated function, I'm going to differentiate it implicitly. Boy, did I word that poorly. Let's d dx both sides. So I'm going to d dx x squared minus 2x plus 5y squared equals the d dx of 1. The derivative with respect to x of an x is just the regular old derivative, don't overthink it. The derivative of negative 2x with respect to x is negative 2. However, when I take the derivative of a y, I'm still going to take the derivative like I normally would, but attach dy dx, like so. That's going to equal nothing. Now that I have all this stuff on the left, I have to isolate dy dx. So let's get rid of 2x by subtracting it from both sides. Let's get rid of 2 by adding it to both sides. That all crosses out and leaves me with 10y dy dx is equal to negative 2x plus 2. Divide both sides by 10. Y. That was not me asking a question. I just forgot to say the letter y. And now dy dx is equal to negative 2x plus 2 over 10y. Those are all even numbers, so let's simplify it a little bit more and make it negative x plus 1 over 5y. I'm not done yet because I have to deal with this point right here. So I'm going to plug in that point. So the instantaneous rate of change, which means the derivative, is going to involve me plugging in negative 1 for x, so double negative 1, plus 1 over 5 times regular 1, which is going to be negative 1 plus 1 over 5, and 1 plus 1 over 5 is 2/5. So instantaneous rate of change is fancy talk for derivative. We had to use implicit differentiation, and when we were done, we plugged in our point, and we get a nice looking fraction there, a very nice, handsome looking fraction. If x squared y plus y squared plus 4 equals 0, then when x equals 2, the value of dy dx is. So we're going to have to use implicit differentiation and d dx both sides. So d dx of x squared y plus y squared plus 4 equals 0. So this involves power rule. So u is x squared, v is y. U prime means taking the derivative with respect to x of x squared, which is 2x. The derivative of y with respect to x is 1 dy dx. Now that's v prime. Okay. Product rule is u prime v, so x squared dy dx. Oh, I have that backwards. Actually, it wouldn't make much of a difference, but if I'm going to be consistent, I want to be consistent. U prime v is 2xy plus v prime u, which is dy dx x squared. That was just this part, by the way. I still have to add the fact that the derivative of y squared with respect to x is 2y, so 2y dy dx. The derivative of 4 is nothing, and the derivative of 0, which I forgot to write out, is also nothing. So let's subtract 2xy, and that gets me dy dx x squared plus 2y dy dx equals negative 2xy. Now let's factor out a dy dx, like that. That leaves me with x squared plus 2y equals negative 2xy. Divide both sides by x squared plus 2y. Divide both sides by x squared plus 2y. And dy dx will equal negative 2xy over x squared plus 2y. Now I have to plug in x equals 2. Oh, poop. I don't know what y is. Oh, but you know what I can do? In order to find y, I could just plug 2 into every x here and solve for y. All right, so instead of x squared, I have 2 squared y plus y squared plus 4 equals 0. So 4y plus y squared plus 4 equals 0. Let me rewrite that out. Y squared plus 4y plus 4 equals 0. Factor that out. Y plus 2 squared equals 0. According to the zero product property, y is going to equal negative 2. So my x is regular 2, my y is negative 2. Now we can plug stuff in. Negative 2 times x, which is 2, times y, which is negative 2, all over x squared, which is going to be 2 squared, plus 2 times negative 2. Wait a minute. You're negative 8. You're going to be 4 minus 4. Oh, actually, you're positive 8. Not that it matters, because that's undefined. My answer doesn't exist. All that. Which of the following represents the slope of the line tangent to the circle given by the equation y squared plus x squared plus y squared equals 9 at any point xy on the circle? Well, the slope of the tangent line is a fancy word for the derivative. And in order to find the derivative of this guy, you're going to ddx both sides because this is implicit differentiation. So I'm going to ddx the left, ddx the right. Taking the derivative of x squared with respect to x is 2x. Nothing crazy. Taking the derivative of y squared with respect to x is me taking the derivative of y, but then also attaching dy dx. Taking the derivative of 9, nothing. Now my job is to find the slope, which means find the dy dx. So let's subtract 2x from both sides, like so. 2y dy dx equals negative 2x. Divide both sides by 2y, divide both sides by 2y, and dy dx is going to equal, let me see, these guys cancel out, negative x over y, which is going to be good old A, baby. Fun stuff, implicit differentiation, boy oh boy. If x squared minus y squared equals 5, what is the value of the second derivative at the point 32? Oh, so much to do. So much to do. So let's take the first derivative. The ddx of x squared minus y squared equals the ddx of 5. The derivative of x squared with respect to x is just 2x, easy peasy. The derivative of negative y squared with respect to x is going to be negative 2y, but attach your dy dx. The derivative of 5, nothing. Now let's isolate dy dx. Let's subtract 2x from both sides, like that. Negative 2y dy dx equals negative 2x. Let's divide both sides by negative 2y. And dy dx is going to equal, let's see, negatives cancel out, 2's cancel out, just regular x over y. All right, that's nice. Now that's my first derivative. I now need to take the derivative of that, which means quotient rule, u prime v minus v prime u over v squared. In this case, u is x, v is y, u prime is the derivative of x with respect to x, so 1. V prime is the derivative of y with respect to x, so dy dx. And v squared is y squared. Okay, so d, the second derivative, is going to equal u prime v, so 1 times y, minus v prime u, so dy dx, x, over y squared. So u become y. How in the world am I going to deal with that dy dx? Oh, wait a minute. Dy dx is just x over y. So I'm going to replace dy dx with x over y. How nice. Times x all over y squared. So let's simplify this just a little bit further. Y minus x squared over y all over y squared. Now I have this point 3, 2. You're an x, you're a y. So using that point, I can replace every y with 2 minus every x with 3, so 3 squared over y, which is 2, all over y squared, which is 2 squared. So we get 2 minus 9 over 2 over 4. Let me see, 2 is going to be 4 over 2, so 4 minus 9 is negative 5 over 2 over 4, and I'll put it over 1 so I can just multiply the top and the bottom by a fourth like that. That crosses out, and we end up with negative 5 over 8, which is u. Oh, so much fun! So much fun.